Saxon Algebra 2, Lesson 42. Our topic is estimating with scientific notation. And John, in just a grand sense of tie-ins, is taking the answer from our problem at the end of the last lesson. So I'm going to copy this up here. That's where we're going to start working on the first example of this lesson. And there are just 4. This is a heavy lesson. There's a lot of crazy calculations, but it's straightforward and there's only 3 problems. All right, so he wants us to take that same problem, which was 16 times 5280 to the third times 12 to the third. Cubic inches, but we don't need the unit. And he wants us to use scientific notation to estimate what this product would be. Okay, so what we have to do is we have to take each of these numbers and convert them into scientific notation. All right, diving in. The decimal is not in the right place. Remember, we want our decimal to be there. So this is going to become 1.6 times 10 to the 1 jump. We want this to get bigger, right? Because we want to turn this 1.6 into a 16. So that stays positive. Done. All right, this guy needs 1, 2, 3 jumps. And we're going to round to the, oh, well, let me just do it this way. 5.28 times 10 to the 1, 2, 3, right? We'd want this to jump out 3 jumps. And then we have to do that 3 times, right? And then 12 becomes 1.2 times 10 to the 1 jump, so positive 1, also cubed. Right? Whew, okay, we're doing fine. These exponents save us from having to write the same thing out a total of 3 times. All right, now what we're going to do is round these lead digits. We don't want all these decimals in here. So this will become 2 times 10 to the first power times, this will round down, right? 5 times 10 to the third, and then we'll do that 3 times. And this will round down also, 1 times 10 to the first power, 3 of those. All right? This looks very reasonable, doesn't it? So now what we want to do is pull all of the lead numbers over here. It will be 2 times, and then we'll have 3 5s, and then 3 1s, right? Those are the lead digits. And this, no, these are the exponents that tell us how many times to use it, all right? 2 times 5 is 10. 5 times 5 is 25. So this means it's our lead digit simplifies to 250. But again, we want this guy to be a proper scientific notation. So this becomes 2.5 times 10 squared, right? Because we have 2 jumps. And then this will round to 3 times 10 squared. When we round, we don't adjust those. All right, now let's deal with all of our powers of 10, right? That was one side. So we've got 1 here. And then we've got 3 plus 3 plus 3, and then we've got 1 plus 1 plus 1. Does that make sense? We're adding up, we're using the product rule to add up all of these powers of 10. This is a 1, this is a 3, but we have to do it 3 times, and this is a 1, but we have to do that 3 times. So this adds up to, let's see, this much is 10, 13, 14, 15. So this will be times 10 to the 15th. Why is my answer? Oh, no, this is 10 to the 13th, sorry. I can't add 3s and 1s together, you guys. This is 10 to the 13th. So that's there. And then it's in our last step that we combine these two and we get 3 times 10 to the 15th. That is our estimate of what the answer should be. And John runs it through his calculator and says, this is our estimate. And John runs it through the calculator and he gets scientific notation value of 4.0697 times 10 to the 15th. And this is reasonably close, isn't it? We have the same power of 10 and our digit is off by a little bit, which makes sense because we did a lot of pretty aggressive rounding there, didn't we? All right, yay for us. This is the answer we want. We only want the estimate. John just showed us the actual. At this point, all we're doing is estimating. We do not have to use a calculator to find the actual. All right. 42.2, ready? Use scientific notation to help estimate the answer to this problem. And what I'm gonna do is I'm gonna give myself room to work. So I've got room up above. There's my division line. These are big burly numbers, aren't they? Which is exactly the point, is that if you're gonna be cranking these through a calculator, you wanna make darn sure that you're working carefully, because a few decimal places off and you'd have a wildly different answer. The hardest thing about these problems is just, it's a lot of, it's, 1, 2, 3, 4 little problems, and then the big problem. It's a lot of work. They are a lot of work. So let's do our rounding as a part of this step. So I'm gonna move this 1, 2, 3 times. It's gonna be 10 to the 3rd power, and it's gonna be 3.7, and that's gonna round to 4. So the first one will be adjusted as 4 times 10 to the 3rd. And now I squiggle that out so I don't double count. This time, 1, 2, 3, 4, 5, 6 jumps. No, I did that wrong. 1, 2, 3, 4, 5 jumps. So that's gonna be 10 to the 5th. When I combine, and then it'll be, let me not combine it yet. This will be 4.7, which is 5 times 10. I did 5 jumps to fix this, but I had the negative 14. So this is going to be negative 9. I add those, right? I can take that out. Let's jump this one. 1, 2, 3, 4, 5. 2.7 becomes 3 times 10 to the 5th. And this is going to be a negative value, isn't it? Because it has to move 1, 2, 3, 4 times. It'll be 10 to the minus 4. And then this I'll round to 7, 7.13 times 10, and then I add those, 10 to the minus 9. All right. I feel good about it. So now let's take our lead values. It is 4 times 5 over 3 times 7. That's 20 over 21, and that will round quite nicely to 1, won't it? Times 10 to the, we can combine these, 3 and negative 9 is negative 6. And then we subtract the bottom ones. So then we do minus 5, but then we do plus 9. This much is negative 11, plus 9 is negative 2. So there's our final answer. And we check to make sure sometimes this digit will go crazy on us and turn into a bigger number and we have to adjust it back, but this one's fine. All right, that's the right answer. And we have one more. I don't want to squeeze it in. These problems need a lot of breathing space. You guys, it is such a break on your brain to allow a lot of white space in between these problems, in among these problems. If you try to cram it in together, you'll save some paper, but guess what? In the long run, that is not the most important thing. Spread your work out, give it some white space, give it some margin, and it will be so much easier on your brain, your eyes, just to even look at it and to follow what you're doing. Use scientific notation to help estimate the answer to. These are even crazier numbers. I have this problem where sometimes I make the dot for multiplication and sometimes I make an X. It's hard to explain. There's no reason. And this is all over. This time, no, we do have two. No, we just have one. 9764 times 10 to the minus 23. Now, what's happening is that the problems aren't really getting harder, but the numbers are just getting bigger and hairier. It's just a little more confusing. All right, 1, 2, we want the decimal right there. 4.18765 rounds to 4 times, let's see, we moved it 10 to the negative 2 times there, right? Because we would want this to get smaller. And then we combine those two, so it's 4 times 10 to the minus 16. There's our first bit. All right, this decimal, 1, 2, 3, 4. This will round to 4. This will be times 10 to the 4th. Notice that I'm using more shorthand in doing these. Last year I wrote everything out in multiple steps. I'm expecting you to carry more of this work in your head at this point. If you need to write it out in more detail, that's fine, but I'm trying to show you just sort of like a note system for combining. Okay, this is 10 to the 4th, that's the 43rd, so this is 10 to the 47th. Okay, so all of this goes away, and that's what I've got left. I'm going to squiggle those out too so I don't get confused. And now we just have to fix this one. 1, 2, 3. 9.7 is going to round up to 10 times 10 to the 3rd, right? But now I still don't have, this isn't proper because I rounded the 9 up to 10. So I need to bump this one more time. That becomes 1 times 10 to the 1st power, that's this much, times 10 to the 3rd, times 10 to the negative 23. All right, so that becomes 10, this is positive 4, negative 23, that's minus 19. 1 times 10 to the. See how I did that? When I rounded, I made this 9.7, which was cool, and I had 10 to the 3rd, but then when I rounded this 9.7, it became 10 times 10 to the 3rd, and I don't want 2 digits here. So I bumped it over one more time. I wrote it as 1 times 10 to the 1st power, because there's the 1 jump, and then I combined it with the 3, and that gave me 4, right? The 1 plus the 3 gave me 4, and then I combined the 4 with the minus 23, and that's how I got the minus 19. Whew, that's a lot, right? Squiggle it out, don't need it anymore. Now let's combine our numbers. It's 4 times 4 over 1, which equals 16. Gotta bump it again, you guys, because we don't want 2 decimals in our answer. So this becomes 1.6 times 10 to the 1st power. I round this 2 times 10 to the first power. But now I need to gather up all of these other signs, right? So for my powers, it's going to be minus 16 plus 47 minus a minus 19. So that's plus 19. Wow. These two go together and I just get plus 3. So that becomes times 10 to the 50th, right? When I add together, right, I've got minus 16 plus 47. I'm using the product rule. Then I shift to the quotient rule because I'm downstairs. Where was I? I was at minus 19. So minus, because that's the quotient rule, a negative 19 means I'm adding 19. Let me just write these down again. You should have these burned, seared deeply into your brain, but I know you don't. That's the product rule. That's what we use to combine on the same level, right? When they're both in the numerator or both in the denominator. When we're trying to combine denominator top and bottom, let's just say, that's when we need to subtract. And that's what I'm saying here. I added the two that were both in the numerator, and then I subtracted the value in the denominator, but I subtracted a negative number, so that turns into a positive. Then I used these two to offset each other, because I see they're really close to the same. If I combine those two, I get a positive 3, right? Minus 16 plus 19. Then I combine the 3 and the 47, and that's how I get the 50. I'm almost done. Now I just have to do, this was the 10 we needed when we fixed the ones over there. So it's 2 times 10 to the 51st. I use product rule again to combine those. This was a lot, you guys. I threw a lot at you in a short amount of time. I hope it makes sense. If not, we'll talk on Friday, as usual, and we can go over anything that's making you crazy. Okay, thanks, bye.